Sorry, I forgot to turn that.
Yes, ma'am. That helps.
Okay, yeah, if it doesn't, please ask, because we're going to continue to kind of use this concept when we're graphing some piecewise functions. So it's kind of a weird little thing, but basically you're graphing just like you normally would. You just stop it at places. Okay, and if not, you just stop me again and we can go back and revisit, because like I said, we're going to kind of continue to use this. Okay. All right. So let's look at, oh, I was going like, what is that? That's the thing I just did. Okay. So, so here is an example of what we call a piecewise function. And it is a function that has restricted domains. And that's what these little x less than 2, x greater than or equal to 2, it's telling me I actually have, it's like I have two functions in one, okay? So I have the function, and this is kind of a boring function. It's just a constant y is equal to 1 for all of the x values that are less than 2. And then I'm going to have a second piece of my function, which is the constant function -3 for all of the x values that are greater than or equal to 2. Okay, so I have this really nice function. It just has two parts to it, depending upon what my x values are or what my domain is. Okay, and just kind of going back real quickly to this one, this is saying this is all of my function for this case, and it is only for the x values between here and here. For example, let's say I look at this function defined with this restricted domain, and I said, okay, well, I want to find f of 3 for this function. And I would have to say, I can't do this, all right? And I can't do this because 3 is not between -3 and +1, and that's all this function is good for. If I look at this graph, x is equal to 3 is way over here, and so there's no point on my graph for this particular function, and it's just based on the way I've defined that function, okay? So that's just another kind of example of what this restricted domain does. And so when we start to talk about these piecewise defined functions, then we start to, and in this case, it has two definitions. It's the value of 1, that's it, that's all there is to it, for any value of x that's less than 2. And then my value is going to be -3 for any value of x that's greater than or equal to 2. So when I come over here to my problem or my questions, I say, all right, for this function f, what is f of -2? So remembering that this is my x value, okay? And so what the first thing I have to do is say, all right, is this x value less than 2 or greater than 2? You're going to tell me that this x value is less. So we -2, I'm going to write this down, because -2 is less than +2, getting that from right here. I'm going to use the first definition. And so f of -2 for this function simply has a value of 1. That's it. That's all I have to do to this. Okay? All right, let's see if this makes any sense whatsoever. X is equal to 0, f of 0. Am I going to use 1 or -3 for my value? You can either send it to me in a chat or you can tell me out loud. Am I going to use 1 or -3? And you're looking at 0 and whether 0 is less than 2 or greater than 2. Yep, I got 1 to me and 1 to everybody, so we're good. Yep. So because 0 right here, this little number right here is less than 2, then we are indeed going to use 1. Okay. So this is the part that I look at. This little part right here is what I'm looking at for these numbers. And then I translate that back to here. Okay. So with that idea, what am I going to use to evaluate f of 3? Remember, I'm looking at this value to tell me which piece to use. Oh, yep, yep. Anybody else want to chime in? You can even chime in with a, I don't know. All right, so this is going to be a value of -3 because 3 is greater than 2, right? Okay, so we're going to use this because 3 is greater than +2. So again, we're looking here, all right, and then we translate that over here to a value, okay? All right, we're going to take this a little bit different, but the same concepts with a little bit different function. Now my function has 3 pieces to it, okay? We're going to use the function f of x is equal to x squared for all of the values of x that are less than 0. So we're restricting x squared to just work for values that are less than 0. Then we're saying that if x is equal to 0, one value there, I'm going to have the point 4. That's it. That's all I'm going to do on that one. However, if all of the values of x for any value of x that's greater than 0, I'm going to use the function square root of x. Okay? So again, I want to evaluate f of -3, f of 0, and f of 9. So as I look at -3 and I get ready to evaluate it, which part of this function am I going to use if I evaluate f of -3? If I need to evaluate f of -3, yes, Caitlin, you are correct. So y'all tell me which part I'm going to use if I want to evaluate f of -3. You can type it in or you can tell me. And you got a 1 out of 3 shot if you just want to guess. Yep. Yep. Okay, so I'm getting some really great answers here so far, so good. So we are looking at this very first part. So to evaluate f of -3, I am going to use this part of my piecewise defined function because -3 is less than 0. And so that means that I'm going to use the x squared part. So I have -3 squared. And so my actual value here is +9. Okay, excellent. So for f of 0, which part am I going to use? Yep, 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 yep. Y'all are amazing. So for f of 0, I'm going to use this part because this says x is equal to 0. This says x is equal to 0. And so the value of this is simply going to be 4. There's nothing else I can do to that. There's no place to plug it in. I just pull that value. Okay. And then finally, I look at f of 9. And hopefully by now we figured out that, well, in this case, we're going to use, because 9 is greater than 0, so that means I'm going to use the square root of x. And so this is going to be the square root of 9, which is 3. And that is my final answer. Okay. So now these kind of went in order. So if you were kind of quasi, you were just like, oh, well, that, yeah, so we got that. So now I'm going to throw another one up here that I don't know where it's going to land. So let's say we're going to call this part D, because that's just a fun thing to call it. And we'll change like the color so you don't think it's going to be color coded or anything. So let's evaluate f of -2. in the chat to me, tell me what f of -2 is. Yep, 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 yep. Excellent. Hey, Clarence. Yep. Excellent. Y'all are like so nice and awake. Y'all are like fabulous this morning. Y'all got this. Okay, so -2 is less than 0, which means we're going to use the x squared. And so that means I'm going to have -2 squared, and I'm going to get a value of +4. Y'all got this. Y'all can do these. Piecewise functions, not so bad. Okay. All right. I'm so impressed. Okay. So now let's graph them. I know, just when you thought it was safe to go back in the water, I threw something else in. But you got this because now you have this idea. So there's a couple of different ways to graph these piecewise defined functions. And I'm going to show you what I think is kind of, I don't know. I don't know there's a perfect way to do these, but I think this is, to me, my favorite way to do this. And that is to really kind of emphasize to you that I do have two parts here. My first part is going to be, and I'm just going to write this as y is equal to 2, but this is only for x values that are less than 1, okay? So here is my domain for this part of my, only for x values that are less than 1, right? Okay, so that means everything that's to the left of 1 is going to work with this function. Now, you can do a table of values, and I might suggest that to you. So x and y, all right? But I only want to select x values that are less than 1, remember? So I'm going to do 1, I'm going to do 0, and I'm going to do -1. I'm going to do these three x values, right? So when x is 1, I'm going to put 2. When x is 0, I'm going to still have 2. And when x is -1, I'm still going to have 2, because it's just 2 for everything, except one of these has to be an open circle. Which one has to be an open circle? And why does one of these have to be an open circle? Putting some things together here. Somebody tell me which one of these has to be open and why it has to be open.
1.
Yep, for +1, it has to be open. And why does it have to be open?
Because it's the last number you can use.
Because, yeah, that's a perfect way to say that, Justin. That was amazing. It's the last number I can use. It's the biggest number I can possibly use, because this says less than 1. There's no equal to under here, okay? And this is the only thing possible. So when I graph this at 1, 2, I am going to have this open circle here. At 0, 2, I'm going to have a closed point. At -1, 2, I'm going to have a closed point. And I could pick, and this kind of goes back to the question we had a while ago, I could pick x values, any x values along through here, and they would produce for me the y value of 2, because I have this horizontal line, but my horizontal line is only good for the x values that are less than 1, okay? And so I have solid points everywhere except for my n, which doesn't have an equals to under here, okay? So now let's do the second part of this function, which is y is equal to -3. And this is defined for the domain of +1 to +infinity, everything greater than or equal to 1. Notice I'm going to put a square bracket on this. And so that tells me that I'm not going to have any open circles on this part of my graph, because everything is going to have a y value equal to -3, and all of my x values will be used. And so I'm going to pick 3 x values that are greater than 1. And for every one of these x values, because I do have this constant function, my y value is going to be -3. And so at 1, I'm going to have the solid point -3. At 2, I'm going to have a point -3. At 3, I'm going to have a point -3. At 4, at 5, I could keep going and going and going. And so when I connect these, my graph looks like this, okay? And we looked at a function, we looked at the graph of a function yesterday and talked about how if it had 2 solid points here, it wouldn't be a function. And that's part of why one of those has to be an open circle, okay? Now, I will tell you on the homework and on the quiz for these questions, I am not going to make you graph it. So you're not going to have to figure out how to draw this graph. These graphs will be multiple choice. What I need you to take from this is, when do I have an open circle? When do I have a closed circle? You know, which direction? So this is -3 for all the values that are to the right of 1. This is +2 for the values of x that are to the left of 1. I need you to recognize those kind of things. Sketching the graph on your own is great because that's a great way to match it up. But recognizing when I have open and closed circles is going to be huge because that's really going to help you out, because these will be multiple choice graphs. But you got to know what you're looking for. Okay. Questions about this one?
I know it was said earlier, but how do you define open circle?
Great question. So it's got to do with the inequality and the round and square brackets. So where I have this round bracket or the no equals to sign under my inequality, that's when I'm going to have my open circles. Okay. Notice that for this one, it has nothing to do with which direction it's going. It's got to do with whether or not the equals to is under here. And so this equals to part on there includes that point, and that solid point says it's inclusive. The open circle says I'm just not using that point. Does that make sense?
Yes, ma'am.
Okay. Some people call these the round brackets. Some people call the round brackets open brackets, and these closed brackets to correspond with your open and closed circles. Okay, so you can certainly do that. So I like to think of the round one as just being round, so it makes that open circle, and then the squared off one says that it's equals to, and I have to include that point. So. But my brain thinks of strange things sometimes, so I apologize if I share this with y'all. All right. Okay, so let's do another one that's a little bit harder because this one's such a nice little constant function. It's not boring, but it's nice. So, okay. So this one has 2 lines that we know how to graph. Okay, and we can graph them lots of different ways. We're going to use some points though. We're going to use the table of values. If you want to graph slope and y-intercept, that's great. Okay. But it's only for certain pieces. So this is a restricted domain of only using x values that are less than or equal to 0. And this one is only for values that are greater than 0. Before I do anything else, let me ask this question. Which part is going to have an open circle on it? The 2x minus 1 or the x plus 2? Which piece of this is going to have an open circle?
The x plus 2.
Perfect. That's it. Okay. So it's not got to do with the greater than or less than. It's got to do with which one's going to have the equal to on it. And this is the one that's going to have the open circle on the end. Okay. So excellent. So let's look at graphing this. So the first one is going to be y is equal to 2x minus 1. That's my linear equation. And it is for all of my values that are less than or equal to 0. So just another way to write this domain. Okay. Notice that square bracket there. So I'm going to have that table of values. And so I'm going to use 0, -1, and -2, just because those are values that are less than 0. Give me nice numbers. They fit on my graph. Right. And when I plug these in, if I plug 0 in here, I get 0 minus 1 is going to give me -1. If I plug -1 in, I'm going to get -2 minus 1, which is -3. And if I plug -2 in, I'm going to get -4 minus 1 gives me -5. Okay, so let's go ahead and graph that over here. Pull this down a little bit. Okay, 0, -1. That's also, you might recognize the y-intercept, right? Yeah, so you might start to recognize that. This one has a positive slope, so when I finish, it should be rising. So if I do this correctly, so -1, -3 is a point, and -2, -5 is another point. I know that's kind of off my chart here, but we get the idea. And so my graph looks like this. Now it keeps going this direction, but it does stop here. Notice I can think about, like I said, the positive slope, the y-intercept, and all of those things, okay? So this is this portion of my graph. So now we're going to do the second portion, which is the y is equal to x plus 2. But in this case, we're going to have that round bracket 0, because there's no equals to here, to positive infinity. So it's only for those x values that are greater than 0. But when I think about my table of values, I just need a starting point. And so that's why I still plug in 0 here. But I just note that I am going to have an open circle. So when x is 0, I get a y value of 2. When x is 1, I get a y value of 3. When x is 2, I get a y value of 4. So my y-intercept here is going to be this open circle, okay? So at x is equal to 0, y is going to be 2, but I have that open circle, all right? So please keep that in mind. So 1, 3 is going to be a solid point, and 2, 4 is going to be a solid point. And as I connect these points with my line does keep going. You can see that it's going to have that y-intercept of 2. I'm just not using that value. It does have a positive slope, so it is rising. So several things there that can go into taking care of things. Okay. Questions about this one? This one is kind of a big deal. So. Questions. Y'all feeling better about these? Or you're still like, nah. Everybody stepped out for a minute to go get their cup of coffee. Okay. All right. So once again, just when you thought it was safe to go back in the water, we're going to do one more thing with these guys. So this is why I didn't want to try to finish yesterday. It would have been totally crazy and insane. These piecewise functions, sometimes we're given the graph, and now this is just kind of, do you really understand what we're doing here? And so now we're going to take the graph and we're going to figure out the rule for it. So hopefully you can tell that I have two pieces of my piecewise function, okay? So it has two parts. So I'm going to say, we're going to call it G, just because I haven't had a G function in a while, and that just, you can call it F. I don't care what you call it. But the first thing I want to do is I want to talk about the domains, okay? So we can see here we have a piece of a function. What are the x values that I'm using for this piece? What is my domain for this piece of the function?
2 to infinity.
2 to infinity, perfect. And is it going to have a round or a square bracket on the 2 here, Justin?
Round.
It's going to be round because of my open circle, right? So the other way to write that in terms of my piecewise function would be to say x must be greater than 2, okay? Now the second part is a little bit different, okay? So what is my domain for the other part of my function?
-4 to 2.
-4 to 2, that's exactly right. And I'm going to have square brackets on both ends because they both have a closed circle. Now, how do I translate that into my inequality notation? I always start on the smallest one, just like I do with the inequality, with the interval, and I'm going to go -4 is less than or equal to x is less than or equal to +2, okay? So this is what the restriction part of my piecewise function looks like, okay? So I've kind of defined that in terms of these are my domains, okay, just to kind of give you an idea on this. So now I have to come up with the actual functions. So the first part is pretty nice because it is constant. And the y value is 3 for all of these points. So I'm just going to say 3 for x greater than 2, okay? Now, the second part is a little bit harder. And so now this is where we're reviewing what we did in section 2.3, which is how to write the equation of a line. And we're given 2 points. And so in order to write, because that's what you have to do. So for the second part, we need to write the equation. We know it's a line. We know it's a linear equation between -4, -4, and +2, +2. And so the first thing we do here is we find the slope. So 2 minus -4 over 2 minus -4. This is kind of feeling a little bit nice here. 6 over 6, which is +1. You might have recognized that you go up 1 over 1 to get to every single solitary point here. And you might have gone, well, why did you didn't? You could have just done it from the graph. That's fine. It is positive, so make sure you do get that positive value. And so now I'm going to use one of my 2 points. I'm going to use the one with the 2 positives. So y minus 2 is equal to the slope times x minus 2. And this is going to give me y minus 2 is equal to x minus 2. Going to add 2 to both sides, and I get y is equal to x. So y is equal to x is my function. And here's y, and it's equal to x for my values of x between -4 and +2. And that's how I write the rule. So that's not so bad. And again, this will be you choose from, okay? So I think so. Anyway, close enough. Questions?
So when it's on like the homework or something, will it like tell us it wants us to do this?
Yeah, it will say find the rule that describes the piecewise function. It'll give you a function. I think for the most part, you are selecting these. I think there'll be a list of these that you choose from based on what you have here. There might be one where you have to tell it what the restrictions are, and you have to define these pieces. You're not going to have to type in all the sweet. People get really worried about typing in some of these funny things, but it would have like a blank here and a blank here, and then maybe a blank over here to fill in. So does that kind of answer your question?
Yes, ma'am.
Okay, perfect. All right. So we're done with piecewise functions. That ends homework number, whatever is 6, which is the one that's due tomorrow night, okay? So don't forget it. Make sure you get it all done. That finishes out that whole homework section. And then we have 3 more sections of what's on this test. This next section is, to me, this is one of my favorite sections to teach because I just love this section about graphing. I think graphing is kind of cool, and I think this is a fabulous way to teach it. But we're going to continue to use some of these concepts. So if you think of other questions, you're welcome to come back and ask me. We're probably going to get done just a little bit. We should get done plenty of time today. So, all right. So section 3.4, this is the material that starts homework and quiz number 7. All right. So this is, like I said, the last set of materials for test number 2. So transformation of functions is all based on what I call our set of toolbox functions. So I'm going to actually go back here, and I'm going to toss in a page that sometimes I have in here. Just a real quick reminder of some things. x squared is our parabola that looks like this, and it has a vertex down here at 0, 0. These are just real, just brief little sketches. Y is equal to the absolute value of x. We did this one yesterday. It is that V shape for absolute value. It also has a turning point of 0, 0. Y is equal to the square root of x. Remember, is the one that starts at 0, 0 and goes like this. And so it has what I call a starting point here. The only thing we're going to talk about today that we haven't graphed in the last like 2 days is x cubed. May or may not have graphed x cubed, but if you graph x cubed, it looks something like this. It twists through 0, 0, and it comes back up like this. So this is the graph of x cubed. Now I tell you this because these are what I call our basic toolbox functions. These are graphs that I hope when you leave this class, if you don't remember anything else about algebra, that you could look at something that had an x squared as its largest power and go, hey, that's a U shape. And if you see somebody says you want to graph the absolute value, you go, oh, that's a V shape. And if you see the square root, you go, oh, that's that sideways half a parabola. And if you see x cubed, you go, oh, that's that little squiggly line. Right? You may not remember anything else, but those 4 functions and an x you need to know is a line. Those 4 functions to me are kind of crucial in terms of what you're going to be doing essentially for anything in this point forward that you would ever use this for, okay? So being able to recognize things. So what we're going to do is we're going to take these functions and we're going to shift them around. I do have, okay. Oh, y'all get to see toys today. That's so exciting. Okay, I know this is kind of a funky little toy. I don't know if you can see my little pipe cleaners in here. Or chenille sticks or whatever you want to call them. So if you remember, so basically what's happening is we're taking, oh, I have some more, I don't know where they are. We're taking something like this, and rather than leaving it here, we're moving it up, or we're moving it down, or we're moving it left, or we're moving it right. Sorry about all the rest of this stuff on here, okay? So that's what we're doing here. We're not changing the shape of, say, the absolute value of x. We're just sliding it around the graph, okay? All right, so, oh, that was fun. Okay, so now, yeah, you can roll your eyes. It's okay. I'm perfectly accustomed to people rolling their eyes at me. It's fine. Okay, so here's what we're going to start with. We're going to start with what we call a vertical shift, okay? And a vertical shift is a shift up and down. It's a shift along the vertical axis, okay, which is our y-axis. And it happens when we add or subtract to the function value, because the function value is our y value, okay? So for example, and I've given you 2 examples over here. So here, this purple line is the absolute value of x, which you should recognize. If I add 3 at the end of the absolute value, it takes this whole function and shifts it up 3. I didn't change the shape, I just shifted it, okay? If I take my function and I subtract 3 from it, it's going to shift the whole thing down 3 units, okay? Everything shifts, okay? So adding to the end of the function shifts upwards, subtracting from the end of the function shifts downwards, okay? And so we're going to employ that. Now, I'm going to tell you, when we graph in this particular section, in the last section, we did a table of values because I just thought that that was really good in terms of breaking things down. If you want to use a table of values to graph absolutely everything in this class, that's amazing. That just means that you're going to always get it right, and I'm so happy. But I am not going to use a table of values in this particular section. I am going to base everything we do on these, what we call transformations and translations, okay? So we're going to be saying, okay, we're going to take this and we're going to move it up and down. And there'll be a couple of times where we find an extra point on there, but in general, we're going to be using these translations, okay? All right, so let's start with this first one that says g of x is equal to x squared minus 1. So the first thing I need you to do is we need to identify what my basic toolbox function is, and then where we're going to shift that function. So I'm going to do this first one, and then I'm going to start asking you guys to help me with the ones after this. So my basic function here, and I just think it's important that you be able to recognize this, my basic function is the function y is equal to x squared, because I see this x squared here, okay? Subtracting 1 at the end of it means that I shift it 1 unit downwards, okay? So rather than turning here at 0, 0, it's going to move down and it's going to turn at 0, negative 1. That's going to be my turning point, okay? Now, if I graphed the other one, and I'm just going to sketch this little graph here. So this is my x squared, and I'm just going to sketch it real briefly here. And this is just x squared because I want you to see what's happening. So this is y is equal to x squared, okay? I'm literally taking every point and shifting it down 1 unit. And so for my new function, everything is going to shift down. Now, if you want to check a second point, and I will tell you there's a couple of these quadratics where you're going to have to actually plot the points on here. So you would plot your turning point first and then one of these points. I could find a second point just to make it pretty by saying x is equal to 1. And if x is equal to 1, then I would plug 1 in for my x, and I would square 1, and I would subtract 1, and I would get g of 1 is equal to 0. And so my point would be 1, 0, and that just kind of confirms this, okay? So here is my graph. Comes down, goes back up. That's so bad. It wiggled where it wasn't supposed to. So anyway, get the idea. Dum, 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 dum. Okay, lovely. And this is g of x is equal to x squared minus 1. Most of these will be multiple choice, so you'll be kicking the graph, which I think sometimes makes it harder because you've got to make sure you know where it shifts, okay? But the idea is to take x squared and know where it shifts down 1. Questions? Okay, so I'm gonna see if y'all are ready for this because we're gonna do one. Y'all are gonna do this next one. Okay. First thing, identify for me the basic toolbox function. So my basic function is y equals what? Chat it or say it. Either one. I am open to suggestions. And then everybody is going to tell me where it moves. I just need one person to tell me what my basic function is.
Square root of x.
Yes, perfect. So y is equal to the square root of x is my basic toolbox function. Now, privately in the chat, everybody tell me where it moves. And you have to have the up or down part too. Yep, so far so good. Excellent. Yep, perfect. It's just going to go in up or down. It's just going to go in up or down, so be careful there. And if you don't know, you can say, I don't know. That was the first.
I do have a quick question.
Okay, go.
Are any of these ever going to go left or right or just up and down?
They are going to go left and right, but we're going to get to those in a second.
Okay.
You got to be patient.
Yes, ma'am.
It's so exciting, all these things that we can do. Hey, I'm still waiting to hear from a couple of folks. Yeah. There you go. I'm good with, I don't know. Okay. So when we add or subtract to the function, and in just a minute, and Cody, that was I think that was you that asked that. That was a perfect question. We are going to move them side to side, but side to side has to do with x, okay? And right now, this square root is actually the y value. That's what's coming out of my function. And so I'm changing what comes out. I'm not changing the x, I'm changing what's produced, which is my y value. And so that's why it's only a movement on the y-axis. And here, it's going to tell me exactly where it moves. So it is going to shift up, and it's going to shift 2 units up, okay? So the basic y is equal to the square root of x is that curve that starts here and goes sideways. So rather than starting at 0, 0 now, it's going to start up here at 0, 2, and it's going to look like this. And that's really all you have to know. You have to be able to pick the graph out that shifts square root of x up 2 units. If you want to use a table of values, and those of you who are going in, yeah, I don't know, you can plug in x is equal to 0. If x is equal to 0, I get the square root of 0 plus 2, which gives me 2. So 0, 2 is a point. If you plug in 1, you get 3 as your point. My graph's kind of funky here, but you get, I'll make it prettier. That makes me sad that I couldn't do that. So, okay. So here is my graph. Okay, that doesn't look a whole lot better, but anyway, at 1 we get 3. I can't use any negative numbers though because I have that square root, okay? So hopefully that makes a little bit more sense. Let's look at another one. Basic toolbox function. So my basic function is the y is equal to the absolute value of x. We're starting to get that idea. Where is it shifting? Up, down, left, or right? Well, up or I'll just tell you up or down. Yep, 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 yep. Yep, yep, yep. Okay, so the -3, if I plugged 0 in here for x, so rather than my absolute value turning at 0, 0, okay, then if I plug 0 in, it's going to be 0, -3. And that kind of helps me out. So it is going to shift down 3 units, okay? So rather than turning here absolute value of x, and that's why it was important you knew that, absolute value of x turns at 0, 0, but rather that it's going to turn here at 0, -3, okay? And then it's going to go like this, and like this, and there's my graph, okay? And you are welcome to put all of these things together that we've been talking about, like intercepts, and if you set this equal to 0 and solve for x, you would get 2 x-intercepts, one +3, one -3. So there's lots of things you can put together. You can do a table of values, okay? There's absolutely nothing wrong with relying back on some of those things we've been talking about, right? So minus goes down, plus goes up, right? All right, let's look at one more of these guys, okay? X cubed, that's my basic function, is that x cubed. And that's that squiggly line, okay? That's the x cubed. And it squiggles through 0, 0. So x cubed always squiggles through 0, 0. And this +1 at the end is going to shift this 1 unit. and it's going to go 1 unit up, okay? So rather than squiggling at 0, 0, it's going to squiggle at 0, 1. And if you wanted, once again, if you wanted to plot some points, you could plot some points. It would be great and amazing. And if you don't, then you just need to recognize that it comes up and it curves and it squiggles through and it keeps going and it looks like this. But it literally looks like you took this little thing and you squiggled it through there and it just moved up. The whole thing moved up. I'm trying to find it. I can't find it. Questions. So adding and subtracting to the y value to the actual function value moves it up and down. We're going to look at what happens in just a second. Okay. So you ask about side-to-side movements. So those are our horizontal shifts. And since our horizontal axis is our x-axis, this is where we're going to change our x value. Now, if you recall, we talked about circles. And we talked about how if you took what was inside that parentheses and set it equal to 0 and solve for x, you figured out where the center of the circle was. So the same kind of thing here, which basically means it's the opposite. All right. So if you can either remember set it equal to 0 and solve for x and figure out where it moved to, that's fine. Or if you can simply remember that your horizontal movement is the opposite. So if it says plus c, then it's going to move left that number of units. If it says minus, it's going to move to the right. And so my absolute value of x is my V shape here. If I did plus 3 inside, now notice I'm inside that absolute value, and this is that big difference. The vertical shift was the absolute value of x plus or minus something. This is the absolute value of x plus or minus something, okay? Subtle difference, but it's huge, okay? So if I'm changing the value of x, I had 3, I moved it to the left, so here is negative 3. Subtract 3, I'm moving it to the right over here to a positive 3, okay? Didn't move it up or down, I just moved it left or right, okay? So this one's a little bit tricky, just got to remember it, okay? So again, first thing we identify is our toolbox function, which is the square root of x. It's going to go 4 units because there's a 4 there, okay? Minus 4 tells me it's 4 units to the right. Now, square root functions, you can go back and employ some of the things we've been talking about. Domain. What is the domain of this function? So just kind of a refresher, putting some things together. The domain we find by taking x minus 4, setting it greater than or equal to 0. I find that x must be greater than or equal to 4. All right. Well, that makes sense then in terms of my basic square root function starts off at 0, 0. Now I'm saying I take it and I shift it 4 units to the right. It starts here and it goes up. Well, that kind of makes sense in terms of my domain, I hope, because I can't have any values that are less than 4. All of my x values must be greater than or equal to 4. Okay. So I'm subtracting 4 from my x, so I'm changing my x value, which moves it side to side. That subtraction, once again, you can take x minus 4, set it equal to 0, and says, okay, my turning point here, or my starting point is going to be 4, right? Or you can say, it's just going to be the opposite. If it's inside, it is the opposite. If it's outside, it's true. If it's inside, it's the opposite. All right, I'm going to see if you got this. Okay, basic toolbox function, x squared. It's going to move 3 units because I got a plus 3. Which way is it going to move? Yeah, one answer, yes. Yes, yes, yes. Excellent. Okay, so it's going to move 3 units to the left. Again, x plus 3 equals to 0 tells me x is equal to -3. So that means it's going to be over here. So remember, x squared had a turning point of 0, 0. So now its turning point is going to be over here at -3, 0. Because it's the x squared, you could pick a second point if you wanted to. Those are the only ones that, some of these will be multiple choice, but the x squared, the quadratics are the only ones you'll actually have to graph in a couple of instances on the homework problems. So if you wanted a second point just to validate or verify, I would pick an x value 1 unit to the left or 1 unit to the right of this x value. Just gives you a nice number. So let's go -2. So that means we need to find g of -2. -2 plus 3 squared is going to give me a y value of 1. So -2, 1 is going to be a point. This is one of these functions that has symmetry, and so I might recognize that. It's just not possible for me to draw a nice curve, I'm sorry. Okay, but it took x squared, my u, and it shifted it 3 units to the left. Okay. Absolute value of x is my basic toolbox function. It's my V shape. It's going to shift 1 unit to the which way is it going to go? Yep. It is going to go 1 unit to the right. So rather than turning here at 0, 0, it's going to turn over here at 1, 0, and then it's going, oh, that's terrible. And it's going to, that's still not very good. But, okay, technical issues I can't draw. Okay. I'm going to make this side look better too. Oh, well, that's not a whole lot better, but anyway, that's it. Okay. Questions. Okay, so I'm just going to forewarn you, the multiple choice questions, so mean. I really am. I'm really not. I just got to make sure you know the difference. So one of them will be shifted to the left, and one will be shifted to the right, and one will be shifted up, and one will be shifted down. Sorry. It's important that you know which way it goes. If it was a trick question, I wouldn't tell you. So I'm telling you, so therefore it doesn't make it a trick question. So good, excellent. Okay. All right, so the next thing we're going to do, and we are going to put all this stuff together, so just in case you're wondering, we are going to put all of this together. It's going to be absolutely amazing. So one of the other things we can do is we can reflect about the x-axis. We can reflect about the y-axis, we just don't in here, just because it's not very meaningful to what we want to do. But the reflection about the x-axis is really important. And so if you have a function which simply has a negative in front of the function, it's going to flip it upside down. So for example, you kind of can't see this very well. I don't know, it doesn't look very good. This should say f of x is equal to negative the absolute value of x. That's what this red graph is going down. So absolute value of x goes up. All of my values are positive. Remember, the range for the absolute value is all positive numbers. We make it negative and it flips upside down. Okay, the whole stinking thing flips upside down. And so now the range becomes negative infinity to 0. Okay? All right, so flipping these things upside down. So negative x squared means rather than going up with my x squared, it's going to go down now. That's it. That's all it does. This is reflection across or about the x-axis. It just flips it. It flips it upside down. All of my values now become negative. All we did. We didn't slide it around at all. We just flipped it upside down. Okay. That's all we're going to do with that one. Okay. The other thing we can do is we can do this thing called vertical stretches and compressions. Now this one, I would probably tell you if you wanted to do a table of values, it's not a bad thing. This one's a little bit harder, but the general concept is we are changing a little bit of the shape. See if I can find my little thingamajiggy here. Let's see. I know you get to see the little toys. See, if you came to my office and you could see all these really strange things that I have in here. Okay. I'm trying to, there we go. Okay. So what happens with these stretches and compressions, rather than taking this and just moving it up and down and left and right that we've been doing, now we're going to take it and we're going to make it narrower, okay? Or we're going to take it, the basic shape, and we're going to stretch it out like this. We're going to widen it out, okay? So we're going to compress it. And it's basically, it's a compression that's closer to the x-axis, and it's a stretch that stretches up towards the y-axis, okay? So we call those stretches and compressions, and they have to do with what the number is in front. So if you look at the graph over here, the graph of x squared is the purple one, and when I multiply x squared by a positive 3, now we're not talking about any negatives here, we're just talking about multiplying by positives. The negatives are going to flip it upside down, okay? When I multiply by a positive 3, it stretches it, okay? It makes it go up narrower. It gets closer to the y-axis. But when I multiply it by 1/3, right, then what happens, 1/5, not 1/3. When it multiplies by 1/3, it widens it, it compresses it. It gets wider, it gets further away from that y-axis. And so that's what's going to happen to these. I need you to be able to verbally recognize when it's going to be a stretch and when it's going to be a compression and what that stretch or compression is. The nice thing about MyLabs Plus or MyLabs Math is that most of these graphs, it's going to have a slider on it, which just is really simple if it's not multiple choice, okay? And by a slider, I mean, if you click on the graph and make it big when you get ready to do this, it's going to have like a little thing down here that allows you to change the value of A, and then it's going to graph it for you. It's really nice, I promise. Guarantee you, if you have any questions, you holler at me. Okay, so let's look at this. Y is equal to the absolute value of x is my basic toolbox function, okay? This 3 in front of this is going to be all of these are going to be vertical, a vertical stretch by a factor of 3, okay? Now here's what I'm going to tell you. It's not going to shift at all, so it's going to turn at 0, 0. I would pick an x value of 1, and I would find that if you put 1 in here, you're going to have the absolute value of 1 times 3, and so I'm going to get a y value of 3. And I would probably tell you to plot this point. And then knowing that it's going to be the same on the other side, and then this is going to give you your graph, okay? And like I said, most of these will be multiple choice, so that you will be basically looking to see, you'll be basically looking to see, is it narrower or is it wider, okay? So on the test and quiz, these will definitely be multiple choice. Right? X squared is my basic function. So I'm going to take x squared. This is going to be a vertical compression. So it's going to be looking wider. It's a vertical compression by a factor of 1/2. Now, 1/2 is the same thing as 0.5. So if it's on that sliding scale, then you can slide it over here to 0.5. And so once again, it's not going to slide at all from 0, 0. I would probably pick an x value of 1 and see what happens. That's going to give you 1/2 times 1 squared, which is going to give you a y value of 1/2. giving you that nice ordered pair of 1, 1/2. And so it's going to be this wider graph. And so it's going to come along and look like this. Okay. Questions? All right. Y'all bear with me for just a second. I'm probably fixing to make your screen gray out. But just bear with me for 1 minute and think with me through some things for a second. And I want to show you, I think I can show you what I'm talking about. So let's see. I know it's terrible to not be able to see this picture. Let's see. I know you can't see this. I'm so sorry. I am so sorry. Okay. That's not what I'm looking for. I thought I took all these questions off. I'm gonna be so mad. I think you just got like a bonus because I think I'm gonna tell you that I didn't put any of those on there. Okay. Anyway, all right. Scratch that idea. Yeah. Okay. So yeah, I'm talking to myself. I know that. I'm sorry. Okay, we're back to here. Okay. Don't worry about these. The rest of them you do. The stretches and compressions, don't worry about them. Everything else you got to worry about. You will see on your homework. Okay. Anyway. All right. I knew I was taking some problems off your homework. So you're welcome. Merry Christmas, Happy New Year, and all those things run together. But you do have to do everything else here. So if you have multiple things happening, okay, this is the order you're going to do them in. You're going to do your horizontal shift first. You're going to look for any stretches and compressions. You're going to reflect it about the x-axis. And the last thing you're going to do is going to be your vertical shift. Okay. So if you have all 4 of these things, this is the order you're going to do them in. Right? All right. So here we go. X plus 1 squared minus 2. Basic toolbox function, x squared. I need you to tell me what I'm doing. I am going to tell you, there is no reflection here. There is no compression or stretch. There is only a horizontal shift and a vertical shift. And so we're going to be shifting it 1 unit somewhere and 2 units somewhere. So I need everybody to tell me 1 unit, left, right, up, or down, 2 units, left, right, up, or down. Yes, I have 1 that's correct. Okay, I'll let you know if you've gotten it correct. If you don't have a yes from me, you are not correct. Go back and look at what we've been doing. Remember, one of those is a change in X, and one of those is a change in Y. Remember, the change in Y goes up and down because my Y-axis is up and down. Change in X is going to go side to side. So go back, match it up. Need to get some more responses. So the question I'm asking you is, I'm taking x squared and this +1 here moves it somewhere, and the -2 out here moves it somewhere else. Okay, so what I want to know is the +1 in here, where does it move? So 1 unit, is that going to go left or right or up or down? And then the 2, -2 at the end, is that going to go left, right, up, or down? And remember, you can always do something to try to figure it out. It's okay. It's okay. We're going to get this. This is the, like I said, and honest and truly, at the end of the day, when you walk away from this, you can go back and plot a set of points. You can do a table of values, and that's an amazing thing to do. There's nothing wrong with that. Okay. So I'm getting some responses, and I'm not quite able to keep up because y'all are really super fast on this. So let's talk about this. So my adding 1 to the x. Here's the first thing we need to establish. If you change the x, okay, inside, that's inside the function, whatever it happens to be. X squared is the function, so inside the x squared. If I change the x, it is left or right, hands down, okay? So this movement right here, adding and subtracting to x, is going to be my horizontal movement. Okay, so this is going to be side to side. And if you remember, horizontal is going to be the opposite. So it looks like it should be that +1, but in reality, if you take x + 1 and set it equal to 0, you get x is equal to -1. So this is going to be 1 unit shifted to the left, okay? It's going to be that 1 unit shifted to the left. So that horizontal, think back like the circles, we had to change the sign to figure out where that center was, okay? So I had to change the sign to figure out where it moved to. But the huge thing is that you realize that that 1 is a left and right movement. That means that the 2 out here at the end is going to be up or down. And it is exactly what it says. So it's going to be 2 units down, okay? So rather than having f of x is equal to x squared, and I'm just going to sketch my x squared in here. So this little graph that I'm just going to dot out for you is going to be x squared. And so here is x squared coming along, coming along, coming along. This is y is equal to x squared. So what I'm doing with my new function is I'm going to take 0, 0, and I'm going to shift it, because we said we were going to do the horizontal shifts first. So we're going to shift it 1 unit to the left, and then we're going to shift the whole thing down 2 units. And so rather than turning here, now it's going to turn here, and I'm actually going to get, my graph is going to look like this. So it's going to come down, and this will definitely be multiple choice, guys. You don't have to stress over the graphing and the fact that, you know, picking points or whatever, that's a terrible looking graph. I'm so sorry, but you get the idea. So it starts here, it shifts over to the left 1 and then down 2 units. And this is my graph of f of x is equal to x + 1 squared minus 2. Okay. Now let's do another one of these and see if we can make it just a little bit more confusing. I know, just because it's fun. I'm just kidding. I don't want you to be confused. Okay. So this one actually has 3 things happening. Okay. All right. Some of you got to have confidence. You know what? And if you send it to me privately in a message, nobody else knows what you put on here. So take a shot. So I promise I'm not grading you on this. I'm going to grade you on the other stuff. So send me a message and you can say, I don't have any idea. Or you can tell me all kinds of things. And I promise I won't give away your secrets. Okay. So I kind of like this chat thing if I can remember to watch it. So in this particular problem, this -1 right here, okay, is going to flip it. So it's going to be an x-axis flip. That's what the negative is here, okay? The -1 in here is my which way movement? Somebody tell me that it's going to go 1 unit to the right, correct. 1 unit to the right, okay? Inside is side to side, okay? So think of it, inside is the side to side movement. It's changing the X value. Which axis is the X axis? It's the horizontal axis. That's what we're changing. So 1 unit to the right. So that's going to be the first thing we do. Then we're going to flip it over. And then finally, we're going to look at this +2 out here at the end, and that is going to be 2 units up, okay? So our basic function is going to be our V shape. It's going to shift 1 unit to the right because that X minus 1, so 1 unit over here. Then it's going to flip upside down, and it's going to shift up 2, okay? So in the end, it's going to be here, and it's going to go down. Okay? And that's what my final graph is going to look like. So I went right 1, flipped it over, up 2. Right? Excellent. Okay. Last one of these, and then we're going to write our functions. Okay. So my basic function is that square root of x. Remember, that's the one that starts here and it goes sideways. Okay. Three. Horizontal or vertical? And then you can either tell me left, right, up, or down if you want to. Open to suggestions. I've only had one answer, and it was correct. It's going to be horizontal. I'm going to tell everybody that because I've gotten that answer. So tell me, is it going to be left or right? Oh, I'm getting great answers. Okay, so it is going to be 3 units to the left. Okay, remember I changed that sign in there. So that means it's going to come way over here. I could also have done the domain of this one. That might be helpful. And then it's going to be 2 units up because somebody told me both of those at the same time. So over here to the left, 3, and then it's going to go up to 2. And so rather than starting at 0, 0, it's going to start here. It's still going to have that basic shape. That's not changing. Okay. Excellent. Okay. So these last couple of problems in this section, we're actually going to figure out what the function is. And so, and then what my new function is going to be based on the shifts. So the first thing I need you to be able to do is to identify the basic function. Hopefully by now we've all figured out that the basic function is x squared. So my question for you is, so the basic function is y equals x squared. Where did I move x squared? Where did I move x squared? Left, right, up, down, and how many units? Ah. That's not good. All right, I've had several people tell me I moved it 5 units to the right, correct? Okay, so because it's a left or right movement, we're going to put the parentheses squared. And I've had a couple of people tell me what to do with this. So because it moved over here to the right, it has to be an x minus 5. Okay, it moved to a positive 5 over here, which means I needed to use x minus 5. And that's it. That's all I have to do. Okay, that's all I have to do on this. All right, let's do one more of these. My basic toolbox function here. What is my basic function here? This one's going to be harder to type in terms of the answer. So you can either write it out or you don't have to tell me where my movement is yet. I just want to know what my basic toolbox function is. Yep, yep. Yep, 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 yep. Yes, yes, I'm getting lots of good answers, including answers I didn't ask for. That's amazing. I love it when you anticipate my questions. Okay, so y is equal to the square root of x is my basic toolbox function. We'll call this one g just for the fun of it. I have the square root of x. My movement is down 2. That's a change in the y-axis. And so it's the square root of x and then minus 2. Notice I'm finishing out this so you definitely see that it's the square root. And then the minus 2 is at the end. That's it. Absolutely. Questions, questions. Okay. So I think what I'm going to do is I'm going to stop here and I'm going to do 3.5 and 3.6 tomorrow. We could probably do most of 3.5 today, but I feel like I've kind of pushed really hard the last couple of days. So this would be 3.5 and 3.6 are the ending of homework and quiz number 7. They're not due until Thursday. So I think we'll be good waiting and finishing this up on Wednesday. And this gives you a little bit of breathing space and allows you to go back and hopefully finish up homework number 6 and start to absorb some of this. We've done a lot with graphs today. And so we're going to do a good bit just working with functions for the next 2 sections. And they do kind of play nicely together, these next 2 sections do. So I'm going to stop here. And if you still got questions on anything, now's a great time to stick around and ask them. If you want to hear other people's questions, it's a great time to stick around and listen. If you want to go work on the homework, it's a great time to do that. It's just a great time to do everything right now. All right, you're up, you're going, you might as well get something done in a positive way. So go grab you a second cup of coffee or a third cup of coffee or a first cup of coffee and go work some algebra problems or stick around and ask me questions. And like I said, we'll do 3.5 and 3.6 tomorrow. A little bit off from the original calendar, but everything else should be good. So, okay. All right. If you got questions, stick around and ask. Otherwise, I will see you tomorrow. Bye.
Did you see the chat, Miss Walters?
I am looking right this minute. Oh, okay. So I'm going to tell you on Canvas. Canvas is so I'm still working with that integration into the gradebook. As long as your grade is correct in MyLab's math, you're good. Okay. the Canvas gradebook is going to be like, it's just kind of an extra bonus for you guys, but the My Labs gradebook is the gradebook. That's the one you really want to look at. So I'll try to make an update later on today. So, but as long as you're good there, then we're set. Okay.
Okay.
Perfect. Yay. Anastasia, Kiera, do you have questions for me?
No,
Or are you
ma'am.
just hanging out? Huh?
No, ma'am.
Okay.
Okay.
Yeah.